Hello everyone, I'm Jordan Gilbert. This is my Module 1 project demo, the Morse Code LED system. So hardware design, pretty simple. Got the Arduino Uno UARTs used to talk to host PC for serial communications. I also use a timer in my design for actually sending the bits out to set the LED, and I just use the onboard LED, which is at port B5 for the GPIO. Quick look at the software. So I use two interrupts. I decided to do interrupt driven IO. So UART, when it receives a byte, triggers an interrupt, and then I store that in a ring buffer. In the main application, do round robin for detecting new data in the buffer, the ring buffer that is, and then I do like incremental conversion to Morse, and I store that in this Morse bit buffer. This buffer size gets me approximately 128 characters. If you have the largest character, which I can't remember which one it is, I think it might be 0, but if you just typed a bunch of zeros, I think you could get max around 128 characters with this. After that, so once you got data, if you hit a Sentinel character, which I support carriage turn, line feed, or Control Z, or if this buffer gets full, then we start transmission, and the transmission is basically just starting the timer. So I've got the timer set up for about 132 millisecond interval, and that will basically just go through this bit buffer, send out the bits to the LED to blink it. All the work is really done in the main application for converting to Morse. System state diagram, kind of already gone over this, but really just, power on, set up the UART and the timer, interrupts and stuff, and then anytime a character is received, we just store it and we start converting as they're stored in the ring buffer. Once the Sentinel is received, so any of these three, I'll start the timer, assuming it's a valid character. If there's no valid characters, you just go back to idle and start over. If there is valid characters, go into transmitting, where you're blinking the LED for the various characters. Really, it's just sending the bits because the translation to Morse has already been done, and then cleanup after that's done, and then you can send another message. A quick sequence diagram that depicts this is like sending hi, so HI, so you send those, that'll get stored in the ring buffer. The main loop picks those up, converts into Morse, stores that in the Morse bit buffer. If you send a Sentinel character such as carriage return, that'll set some flags, start the timer. So then we basically just enter a transmitting state where everything else is ignored. The only thing that's happening is this interrupt is being triggered over and over again at approximately 132 millisecond interval. I did this way to keep the timing for Morse code tight. I felt like it was like kind of clean to do it that way. But yeah, you just go through the bits, set the LED based on the buffer, and then once you're done, clear some flags, and you're ready for another message. So let's give a quick demo. Got my board here. I'll actually do the demo from the sequence diagram. I'll just type in HI and send it. It should be four dots, and then space, and then 2 dots, and that worked out pretty good. You can send, 0, for example. I just sent H0 there on accident, but you got your 5 DAWs. But yeah, that's pretty much it. I'll do the little hello world, and while that's going, yeah, that's my project. Thanks for watching.